G'day girls, welcome to our next Flip Science video. Today what we're going to be learning about is accurately measuring volumes of liquid. Okay, so today we're going to be focusing on how to use what is called a measuring cylinder. So a measuring cylinder looks like this. So here we have our four measuring cylinders, a 100ml, a 50ml, a 25ml and a 10ml. They have lines on them, okay? So what this indicates is how much each line goes up by. If you look between, say, 70 and 80 mil, what you will notice is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Each of those lines represent 1 mil. Not all measuring cylinders are the same. The larger ones tend to be 1 mil. So for instance here, your 50 mil goes up by 1 mil. Your 25 mil goes up by 1 mil as well. However, between 9 and 10 in this case, there are 9. So this is actually going up by 0.1 of a mil. So the large line in the middle is actually, let's say between 9 and 10, 9.5. So here I have my four measuring cylinders. I will require a little bit of additional equipment for what I'm going to do today. I'm going to need a beaker. Here I have a 250ml beaker. We don't actually use this one for measuring. We'll also need a pipette. I'm going to measure two different volumes for you today, and we will work through those now. So to measure 17 mil of liquid, firstly, what I want to do is I want to collect some sample. Okay, so in this case, I'm just going to measure water. Collect a sample in a beaker. Okay, sometimes they will be given to you in a drop bottle. That's fine. If you have a small bottle, again, that's fine. If you have a large container, then we want to just get a small sample of that and bring it back to your workspace. So to get my water, I'm just going to get a small amount out of my tap. I'm only measuring 17 mil, so I'm not going to take a full beaker of water. We want to limit waste. Now, knowing that I want to measure 17 mil, I want to select the correct measuring cylinder. So I have three options. Obviously, my 10 mil measuring cylinder is going to be too small. It won't hold the correct volume. I'm then left with my 25, my 50 and my 100. It's pretty straightforward in how to select these guys. So if you want to measure less than 25 mil, use the 25 mil measuring cylinder. That's what we will use today. If you want to measure between 25 and 50, you would use your 50 mil. If you want to use measure between 50 and 100, you would use your 100 mil. We don't need. Okay, now that I have my sample, I have the correct measuring cylinder. What I want to do is add liquid to the nearest 5 or 10 within my measuring cylinder. So, starting at the bottom I have 0, 5, 10, 15, 20, 25. I'm going to add up to 15 because I'm measuring 17 mil. I'm going to add up to 15 mil using my beaker, and then drop-wise, using my pipette, I will add the remainder. So, I'm going to bring it up to eye level and add 15 mil of my liquid. Now, if you go a bit above, that doesn't matter at this stage. It would only really matter if we were trying to get 15.5 to 16 mil. You'd want to keep it a bit lower, maybe aim for 14. Once I've got it, I need to start getting down to eye level with my equipment and using my pipette. So this is where we're going to add drop-wise or much slower to allow us to get an accurate measurement. So I'm going to squat down, not kneel, get down to eye level with the measurement that I require, and I'm going to add liquid until the bottom of my meniscus is at the 17 mil mark. I will now show you a close-up so you understand what I mean by the meniscus being at the 17 mil mark. So So as you can see, the bottom of my meniscus is at the 17 mil mark when I'm looking square on. So that's how I'd measure 17 mil. We're now going to look at our second volume. So to measure 7.5 mil, less than 10 mil, so I'm going to use my 10 mil measuring cylinder. Again, what I want to do is add liquid up until the nearest 5 or 10. So in this case, I'm collecting 7.5 mil. I'm going to add up to 5, or as close as I can get it without going too far over. So from my beaker, I will pour in the initial part of my sample. Get it as close to 5 mil as possible. Then, same process. We're going to squat down to eye level with it and add using our pipette until the bottom of our meniscus is on this 7.5 mil line. So, squatting down, eye level, and we add until the bottom of the meniscus is at the 7.5 mark. And that is that is our 7.5 mil sample. You may be curious as to why I'm squatting down while I'm doing while I'm collecting my sample. The reason is we have in science something called a parallax error. I'll put a diagram of what I'm talking about up now. Again, as you can see, the bottom of my meniscus is at the 7.5 mil mark. You'll notice when you add liquid to a measuring cylinder, the surface of the liquid doesn't form a straight line, it forms a curve. This is what we call a meniscus. Depending on the diameter of your measuring cylinder, depends on how pronounced the meniscus will be. If it's a very narrow tube, it will be more pronounced than a wider tube. The meniscus is caused by surface tension in the water, which I'll explain separately. So basically, when we look at a line from different angles, it's going to be in a different position. So to accurately measure, what we want to make sure of is that our eye line is perpendicular to the surface. Okay, so in this case, when I'm looking at my measuring cylinder, I want to be perpendicular or 90 degrees to the measurement that I'm looking for while I'm adding my liquid. As you can see, guys, the angle that I look at my measuring cylinder from will actually dictate where the meniscus falls. So we need to look square on, such as in this image. Okay. That's called an error of parallax. It doesn't occur just with glassware, it can also occur with things like rulers. Okay? We want to eliminate that so our measurements are as accurate as possible. So that's it, girls. That's how we measure using a measuring cylinder. Thank you.